Here are a few common types of molar mass problems. So we're going to go over the two basic molar mass problems. We're going to figure out how many moles are in a mass of a substance and how much mass is in a certain number of moles of substance. First, let's start up top. How many moles is 88 grams of carbon dioxide? Now, first we need a conversion factor. Now, that conversion factor needs to convert mass to moles, or moles to mass. It's the same conversion factor. Now, that conversion factor is called the molar mass, it's a ratio of mass to moles. So the molar mass of carbon dioxide, we need the periodic table. So go grab one of those. We know that carbon dioxide is made of 1 mole of carbon. We can get that from looking at the formula. And 2 moles of oxygen. Also, you can get that from looking at the formula. So we know that 1 mole of carbon is 1 times 12.0 grams. And we know 2 moles of oxygen, 16.0 grams. And we can add that up, and we get multiply it out, 12.0 grams and 32.0 grams. And we can add that up. And we can figure out that the molar mass of carbon dioxide is 44.0 grams per mole. Now remember that that is the mass of 1 mole. 44 grams is equivalent to 1 mole of carbon dioxide. So how do we go about doing this problem? Now, I'm going to use dimensional analysis. If you guys like the triangle method, that's fine as well. But we have 88.0 grams of carbon dioxide. And I want to know how many moles I have. And I want to cancel out grams. So now I can just easily plug in my molar mass. I know that 44 grams of carbon dioxide is equivalent to 1 mole. So I plug in 44.0 grams is 1 mole. And then I calculate that. And I notice my units cancel out very nicely. Grams cancels out grams. So I have 88.0 times 1 all over 44.0. And that's moles. Moles is the unit that's left over. And I can do the math, and this is a good problem, and I get 88 times 1 over 44 is equal to 2.00 moles of carbon dioxide. So let's do another good example. Another good example here is how many grams is 0.30 moles of calcium carbonate, CaCO3. Again, we need that conversion factor. So the molar mass is that conversion factor of CaCO3. We need to, again, calculate that. And 1 mole of CaCO3 is made up of 1 mole of Ca, 1 mole of carbon, and 3 moles of oxygen. I get my periodic table, and I can calculate this pretty easily. I look in the periodic table, and the molar mass of calcium is 40.1. Again, round to the tenths. The molar mass of carbon is 12.0. Round to the tenths again. It will help. And there are 3 oxygens. The molar mass of oxygen is 16.0. And I can calculate that, and it's 48.0. And I can add that up. So I get 100.1 grams per mole, and that's the molar mass of CaCO3. Meaning that 1 mole of CaCO3 is equal to 100.1 grams of CaCO3. Now, it's a conversion factor, similar to how velocity or speed represents the ratio of distance and time. even if you're going 30 miles per hour, it doesn't mean you just have to go for 1 hour. You can go 30 miles per hour for half an hour, for 10 minutes, for 1 minute, for 2 seconds, for 12 hours. It's just a ratio that relates distance to time. Now, molar mass relates moles to mass. So let's figure it out. So we have 0.30 moles. Now, it is different for substance, so do pay attention to what you're talking about. And we need to cancel out moles and convert to grams. Now, I can look back up here, my molar mass, and I know that I have 100.1 grams for every 1 mole. And again, notice the unit moles cancel out because we want to calculate how many grams. That's the question. And I can calculate that out, and that is equivalent to 30.03 grams. And that's pretty easy. Note and calculate that. It's just the moles times the molar mass, like we talked about in the triangle, if you're doing it that method. But this is another good skill. Practice it. We're going to be doing a lot of these examples in class, so get it down while you can.